to begin.
Hey, what is up, guys, and welcome back to another episode of the Social Pyramid Podcast. Today's episode is a very interesting discussion on the topic of flat Earth. Now, before I get started, let me give you a quick background as to how this conversation developed and the idea behind it. A couple of weeks ago, I was on Instagram and I got a direct message from David Weiss, who is the host of the Flat Earth Podcast, and actually one of the guests on this episode. So he reached out to me and he told me, like, hey, how will you, would you be interested in having a conversation about flat Earth? He informed me that he had what he calls evidence that can prove that the Earth is flat. So of course, I was like, what the fuck? This sounds crazy. You know, I am not a flat earther. I was taught that the Earth is round. I believe that the Earth is round. So of course I second guessed it and I was like, I don't really see how I can build on this conversation. Because again, I'm not a flat earther. I'm not for the idea of it. So I'm opposed to it. And then I started thinking, why am I opposed to it? Like, I don't fully understand it for me to clearly say, hey, fuck that idea. You know, and it's funny because as humans, it's easy for us to easily dislike something or deassociate from it, sometimes without fully understanding why. Now, I'm not saying that trying to figure out the why is going to change your opinion on it, but it's the asking and digging into the concept of it to try to understand what the underlying emotions are there. And once you know that, once you know what those reactions are, then if you decide to continue dealing with it in the same way, then at least it makes you more aware. You're on another level of awareness, if any of that makes any sense. So that's where the whole idea that I should do this came about. And how I can, find a way or an approach where I can have a discussion that can be both informative and at the same time allow for an open discussion between two opposing sides. So I reached out to Nanoski. He is a science educator. And he knows his shit. That's all I can say. So I was like, you know what? This conversation will be a lot better if I was to bring in two people who are, obviously really good at what they do in their fields. And let's see how we can have this conversation happen where, again, in a debate type form, debate-ish, it's more of an open discussion. The whole idea is that this conversation had to happen. So they both agreed to it. And everybody tried to be as civil as possible, when possible. So I'm not going to spoil anything else for you. I just want to make sure that you guys are aware that this conversation had a lot of thought into it in terms of how I wanted to approach this conversation. I'm not here to convince anybody. I still believe the Earth is round. So unless you have something that can show otherwise to me, to myself, I'm still Team Earth, still round Earth. But with that being said, I hope you guys enjoy this conversation. Today's music is brought to you by Earth Rebel with the song Lovers, They Scatter, End of the Fucking World. You can find it on YouTube. You can find it on Spotify. He's an artist from the Southeast LA area, so local. So if you're listening and you're here in the hometowns, go show him your support. Go show him some love. Give him the follow. Share the music. Enjoy the music. What else? I mean, that's pretty much it. Just do what you gotta do. We'll see you guys next week.
Feeling like nothing gon' matter though. My soul going crazy for antidotes. Too many lovers that scatter hoes, and I'm just living the shadow world. Feels like the end of the fucking world. Feels like the end of the fucking world. Too many lovers that scatter hoes, and I'm just living the shadow world. Feeling like nothing gon' matter, so I'm just gonna relax. Too many lovers that scatter, so I'm gonna stay to the track. Feeling emotional laughter, got this pain in my heart when I laugh. Feeling emotional laughter, got this pain in my heart when I laugh. I'm just gonna smoke and relax, so I'm just gonna stay to the track. I got this pain in my heart when I laugh. I got this pain in my heart when I laugh. I'm just gonna smoke and relax, so I'm just gonna stay to the track. I got this pain in my heart when I laugh. I got this pain in my heart when I laugh. Feeling like nothing gon' matter, so I'm just gonna smoke and relax.
I know for a fact, there's going to be two different perspectives going on here.
Let's just go ahead and just give each other time to talk, preferably not talk over each other, and make the best of it. Just have as much fun as we can within all this.
Sure, sounds good to me.
All right, guys. So we'll start in 3, 2, 1. Hey, what is up, guys, and welcome back to another episode of the Social Primate Podcast. Today, a very interesting conversation is about to happen here. My guest returning for the second time, we have Nanoski. Nanoski, thank you for coming out.
Yeah, you're welcome. Glad to be here.
And the next person on the list here is David Weiss. He is the host of the Flat Earth Podcast. What's up, David?
Hey, what's going on, guys?
Good morning. Good morning. Thank you guys for both making the time to get up early. It was I was thinking the whole night, I'm like, okay, what am I going to talk about? How are we going to discuss this in a way that can be, in a sense, informative to both places and figure this thing out? With that much being said, David, can you give us a little bit of background about how you got to where you are right now?
I was doing a podcast called Deep Inside the Rabbit Hole on conspiracies, and I was introduced to Flat Earth. I absolutely refused to even look at it because it was the dumbest thing ever. But then I was forced to look, and I went in with the purpose of debunking it. And that's how you become a flat earther. Once you understand what the flat earth isn't, and once you understand what the globe earth is supposed to be, then you realize that you've been lied to. So, do I know exactly what the earth is? No. Do flat earthers have different opinions? Absolutely. But one thing we all agree on is we're not a spinning ball in an infinite space vacuum, which defies all the laws of physics.
So now just to kind of reiterate on that or touch base on it, at some point you did believe the earth was round.
We all did. Sure. Absolutely. 5 years ago, 6 years ago.
Okay. So what was that moment that changed that for you?
Well, when I went in to debunk it, I was like, okay, hey, boats go over the curve, and so I started seeing all these long distance videos where we could see far beyond where a ball with a radius, what they tell us it is, would you'd be able to see things would be, you can calculate how far they'd be over the curve. And so saw the videos, but I'm not just going to believe videos. So I went out and bought a lot of camera equipment and super zoom lens. And I zoomed in on things that should be, hundreds of feet below the curve. So then you come into refraction and stuff. But, through time lapses, we see that, there's reasons that things disappear into the distance that doesn't have to do with curve. They're different on different days. So that shows that it's not, not curvature, that it's an optical thing. So that was the number one thing. And then, as we went through, the more and more evidence. So I kind of took it pragmatically. I said, all right, 3 baskets. This works on a globe earth. This only works on a flat earth, only works on a globe earth, only works on a flat earth, and works on both. Lots of things go into that 3rd basket. Lots of things go into the only works on a flat earth, the distances that we can see, for example, and nothing ever falls into the 1st basket. So
if you don't mind me just kind of nitpicking on some of the specific stuff, I had the chance, I haven't personally gone out to the beach and done these whole tests, but I've seen videos that, air quotes debunk this stuff. Oh, thank you for pulling that up. So for the audience, we're seeing basically looks like it's a time-lapse video of the ocean. And you're seeing
it's
boats,
a bay.
right?
It's a non-tidal bay.
And in this case, so we're seeing here the water rise and you see the island a little bit disappearing. Is that what we're looking at?
You're seeing the beach disappear. You're seeing the buildings disappear. And it's just atmospheric conditions because the water is not changing its height. This is just throughout the day where you can look and say, oh, that's over the curve. But then later in the day or earlier in the day, it's not over the curve. So this is provably, not arguably, a optical phenomenon, not a curvature phenomenon.
Okay. And then do you have any input on this?
Well, I would just completely disagree with that. What he's showing there is what I would refer to as a local phenomenon. And then saying that is equivalent to something disappearing over the horizon and making them both equally equivalent phenomenon is, false.
I'll agree with you there. I'm not saying that this proves the earth is flat. I'm saying that this proves that things can disappear and not go over a curve.
But you're equating that with things don't disappear over the horizon. They're not the same thing.
Well, there's different ways things disappear, and it all has to do with atmospheric effects, a thing that I call the wave front edge. You can have a wave that's just a mile or 2 or 3 outside of your vision, and then you're looking at something 20 miles away, and well, that wave is bigger than the shrinking perspective object that you're seeing, so the wave will block it from the bottom up.
I understand. I understand your logic there. I mean, that makes sense. But again, you're still equating that with actual disappearing over the actual horizon.
What have you seen that disappears over the horizon that you can prove is not an optical effect?
Any large object, at some point, it just disappears. There's no more optical illusions.
So let me address that, because I have visuals and you don't. It's fine. So I'm just going to show you. Here's something. You don't see any boat here. It's disappeared, and you can argue that it's disappeared. But as I zoom in and I increase its angular size, all of a sudden you can see the boat. So let me zoom all the way into this boat. Now, when I zoom out, it's the same thing as the boat going away. So we see the entire side of the boat. And as I zoom out, you'll see that the bottom of the boat disappears first. This is because of the wave front edge. And then it goes all the way up to the windows, all the way up to the top. And then the angular size of the boat becomes too small to see. Okay. So this is showing you how things could appear to disappear over the horizon when in fact they just go beyond the angular resolution limits of our eyes, which is 0.02 degrees. Anything smaller than that, even though it's still there, you cannot see it.
Your example of zooming in on that boat, you're showing the limits of human vision. Okay,
sure, absolutely.
We only see 0.0035% of the visible of the electromagnetic spectrum. Human eyes can see less than 1% of all the possible light that exists in the universe. So yes, we're very, very limited. If you kept on zooming, at some point, if that boat kept on moving towards the horizon, you get to a point where no matter how much you zoomed in, the boat would just be gone.
I 100% agree with that.
Even your camera is limited. I
100% agree with that. I 100% agree with that. So, the thing is, it's an optical thing. What I'm showing you here is I'm zooming in on a table, and I have a small object at the far end of the table, and it's there. And when I zoom out, it disappears. And that's due to its angular size and also a miraging of the table. When you're looking across the flat surface, you get a miraging. So let's get off of that. I'll show you something else.
Just a quick thing I wanted to bring up real fast. So I was reading earlier, again, I'm not an expert in any of this, but I was reading on something and that there's 2 particular islands in Hawaii, some of the tallest peaks within that.
You're talking about on a clear day, there's a clear line of sight between 2 peaks?
Yes, exactly.
Yeah, like over 300 miles.
Exactly. Yeah. So according to what I was reading is that if you're standing from the tallest peak, even on a clear day, you technically still wouldn't be able to see the other peak unless you got on a boat and got closer to it. Yeah. So when you talk about large objects like that, like what's the explanation? Like I'm trying to figure out like a way of understanding how something so huge.
There's only one reason that you can't see the other peak. On a flat Earth, you should.
Okay.
But on a curved Earth, it's impossible. And what is the truth? It is impossible.
All right. So let me absolutely tear that apart. Here is a viewing point in Aluja, France, where we're looking out over the ocean, and Mount Canigou is out here at 175 miles away. Using Globe Earth Curve Calculator, the top of Mount Canigou.
Wait, what is that? Well, you're throwing a lot of things out there. We just got to take your word for it.
Well, so no, it's absolutely not. So let me go. You said you weren't going to interrupt. I'll make my point, and then you can counter. You ready? Okay. So this is something you go verify yourself. You can go there and view this, but it only happens twice a year when the sun is migrating in between its path. So Mount Canigou is 175 miles out from this viewing height. The top of Mount Canigou should be more than a mile below the physical horizon, which a glober would say this is. This is not. This is an optical horizon. The reason that you would be able to see something is because light is bouncing off of it. If there's no light, you couldn't see it. It's dark. Mm-hmm. So the light that's bouncing off of Mount Canigou is not powerful enough to push through the thickness of the atmosphere. It's like looking through 100 panes of glass. You can't see through it, but but you can see perfectly through one pane of glass. So 2 times a year when the sun lines up with the Mount Canigou, the sun is brighter. Its light can push through farther. And when it goes beyond Mount Canigou, all of a sudden you can see it. Now, the bottom is a little compressed. We can get into that in a moment, but I don't care that the bottom's compressed. The top of the mountain right here should be a mile below the curvature, but it's not. It's here. It's right there. It's visible, and thousands and millions, I don't know, millions, tens of thousands of people have seen it, and you can go see it yourself. So it's been filmed 100 times. Just go look up Mount Canigou from Aluja, France. There it is. The top should be a mile below the curve. It's not a mirage because mirages don't block the sun. And the Glober argument, just in case you're unaware of it, is the mountain is below the curve and the sun has already said it's just refracting up and magically stopping at eye level. Ridiculous.
It's not ridiculous. That's what's happening. Refraction is occurring. It has already gone over the horizon and you still can see it because of refraction. I mean, for you to say that that's not what's happening means you have to reject so much of what we know about light. Like, I find that really extraordinary that you will use light to make some of your points, but then you'll reject the implications of what we fully know about photons. You're cherry picking. You're picking.
So what do we fully know about photons?
We know that they move at a specific speed.
How do we know that?
We know that speed changes when they passes through different types of matter, solid, liquid, or a gas. We know that they have a wavelength, and they have varying wavelengths. The electromagnetic spectrum, again, which the human eye can see less than 1% of. So we had to invent artificial eyes like telescopes and microscopes in order to be able to see what the human eye cannot perceive. And so, again, you're making your point based on certain properties of light, but those same things that we know about light and know about photons, if you were to fully embrace all of the facts of light, you would contradict yourself.
Okay. Well, I think we can move on beyond this, but I say that all the things that they think they know about photons and where they come from and what they do are pseudoscience. You know, for example, solar panels, they have no idea how they work. They think a photon is knocking out a boron molecule.
I'm an AP environmental science teacher. I teach my students exactly how they work.
And where did you learn that? I mean, the theory on how they work, it's just a theory. They don't know. They don't know. So listen, let's move on.
Technology. It's based on what we know.
That's a word. That's a word.
Yeah.
Technology is a word. Science is a word. Show me the science. Show me the technology.
The science that makes this Zoom broadcast a possibility is incontrovertible science. If it was not proven science, you and I wouldn't be having this conversation through Zoom.
Works perfectly on a flat Earth. Go ahead.
Well, the implications of those laws of physics and those laws of chemistry, those implications reject a flat Earth.
No, they don't.
Yes, they do.
Large bodies of water at rest lay flat. Anything bigger than a bucket of water at rest lays flat. And it's testably, measurably, scientifically, provably flat. We can see the source of a laser where it should be hundreds of feet below the curvature.
You're using light again.
We can do mirror flashes. We can see things, right? If you don't use light, there's nothing to see. Let's look at another example because we can agree to disagree on this one. And
well, you're bringing up lasers. In order to even make a laser, in order to even manipulate light in the way you must manipulate light, to change it so that it's all in the same phase, to actually make a laser beam means we have to know a lot about light. You have to have extremely high knowledge of what photons can and cannot do.
All right. You claim that this mountain and sun have already set below a physical curve.
Technology is a word.
You believe that this mountain and the sun is below the curve and it's refracting up.
I don't have to believe it.
I don't believe it, and I don't have to believe that it's a mirage. So let's look at something else
real quick. So I do know this is just again me. I'm no expert, but of course, there was ancient cultures that at some point or another they did believe or go based off a map, a representation of Earth that was flat. Yeah, thank you for pulling that up. Now, of course, as time progressed and science advanced, you start seeing more things. You know, I think it wasn't until like Plato and some people in Greece started figuring things out or started calculating distances and curvature. Now, with that being said, science at the end of the day is experiments that have been done multiple times by different people at different times to basically prove that this continues to be.
Yeah, reproducibility.
So in reality, if at some point the science did change, then of course the science will mold into that.
Okay, can I address a couple of things?
It's called a paradigm shift. It's happened many times in science's history.
All right, let me address a couple of things, then I'll get on to my next point. You're talking about that they figured out that the Earth was a globe back in 2,000 years ago when Aristophanes did his sticks and shadows experiment, right? Well, his sticks and shadows experiment works perfectly on a flat Earth and a globe Earth. He said he assumed that that light comes in parallel. His stick, his well, whatever he used, the story changed, had no shadow, and then his buddy 500 miles away had a shadow, and he did some math and he figured out the radius of the Earth within 2%. The problem is on a flat stationary Earth with a small local sun, the same exact math could be done. Aristophanes has his stick, no shadow. His buddy has a shadow, could do the same math, same angles, and figure out the sphericity of this flat Earth. Math is not reality. Math is math. Math is accurate with whatever numbers you put in, but you're assuming parallel rays when in fact nobody has ever seen parallel rays come in. Whether they're refracted or not, doesn't matter. They don't come in parallel.
That's just you're starting from a false assumption. You're assuming that the sun is closer, and you're assuming it's small.
You're assuming it's far, and the rays come in. Hold on. You're assuming it's far. Now, how do we hold on? We'll get into that. You're assuming it's far, and you're assuming the rays are coming in parallel when no one's ever seen parallel rays, and you're assuming that it's far because of why? How do you know?
I won't speak for you. How big is the sun?
I don't know. How big is the sun?
You don't know.
I don't know. How do you know?
It's an object in the sky.
Well, so you figure out that. How would you figure out the size of the sun?
We know how many solar units per cubic meter of air. We know how much energy is coming off this ball of hot gas. So you can actually take that amount of energy and you can make crude, just not even without using supercomputers. You could use that data to tell you how much energy is at least coming out of it. And then you can from that point go, well, how big would an object have to be for that much energy to be coming out of it?
So that's how they figured out the size of the sun, by the amount of energy that's coming out of it?
That's one aspect of it. What I'm saying is I've never heard that. How much you're rejecting? Well, that's because you cherry pick. If you actually took the amount of energy that's striking the Earth, it would not come from a small little ball close to the Earth.
I don't think the sun is a small little ball. I don't think the sun is a burning ball of hydrogen. You think this is what you think. You think the sun is a burning ball of hydrogen in a space vacuum. Well, physics says that's impossible. Let me finish my points, and then you'll finish your point, or we'll just end this very quickly. Okay. I let you talk, and now you let me talk. I don't even talk for that long.
Dude,
okay. You think the sun is a burning ball of gas in a space vacuum?
I don't think.
Show me physics that can allow a burning ball of gas in a vacuum. All right. Now you can say gravity and stuff. Let's go on to another point.
You reject gravity. You reject gravity. So of course, if you reject gravity, then stars can't exist.
Yes, the way correct.
If you reject gravity, but gravity is real.
Yeah, let's try not to interrupt each other, guys, so that way we can get each other's points across.
So again, you're assuming stars are giant balls of gas that have gravity. I do not. I think that the stars that we see. You know what? If you keep interrupting me, I'm not going to be able to say anything, and then we're just going to end this. We can have a conversation, but you have to listen occasionally.
Okay.
Let's take a minute, guys. Yeah.
I think I've been listening a lot.
You're interrupting me. You're interrupting every time I talk. You interrupt. I listen to you all the way through. Okay. We'll go if you want to go. Okay. Do you want to go next? I'll let you continue what you were saying because I have no idea what it was.
All I was trying to make a point was that we know what the sun is and what it's made of and what all stars are made of because of what is in the light. There's information in the light.
That's pseudoscience. Sorry, we can disagree. You don't know how far. Listen, so you talked about, you know how big the sun is. How do you know how big the moon is? They're both the same size, approximately the same size. So the math would say they're both the same distance or the same size.
They're not the same size.
How do you know that?
Because we can look at the light that reflects off the moon, and because we know the speed of light, we know that it's much closer.
So do you know what the inverse square law of light is? Sorry for interrupting. Go ahead.
So you're going to tell me that when we look at the spectroscopy of light, that when we're looking at those different bands in like a absorption spectra, you're going to say that those dark bands are not showing that a particular element exists in the sun that's absorbing that particular frequency of light. And that's why we can't see that light. So if hydrogen is absorbing a particular frequency of photon and it leaves this black line where that frequency should have been, that's telling us that there's hydrogen in the sun. You're rejecting that basic quality of light.
I wasn't going to say that at all. What I was going to say is, this is the moon, a full moon in your middle of nowhere on a clear night. You can read by it. It's cast shadows on the ground. It is sourcing light at us. Then NASA will show us a shot of the moon from the far side where there's a full moon and there's no light. It's not a light. You can see when the moon is in the sky and there's clouds in the sky that the moon is a local light, because if the moon was 238,000 miles away, it would light up all of the clouds. There wouldn't be darkness over here. The moon, the light that we see in the sky, it is a light. It is a cold light, and it is local to the Earth. But if you want to get into the inverse square law of light, do you know what that is? I can explain it if you need me to.
Explain it.
The inverse square law of light says, this is your science, and it is measurable and testably provable. Light spreads out when it's going. So you have a source light right here, and an inch in front of it, that light is, I don't know, whatever the number is. And as it goes, it spreads out, and it doesn't stay as intense. It spreads out in an inverse square root. So when you double the distance to a light, it's 1/4 of the distance. You double that, it's 1/4 of that. So if you went halfway to the moon, to this lit up moon, it would be 4 times brighter. So let's just say this is 1 lumen. If you went halfway to the moon, it's 4 lumens. You went halfway again, it's 16 lumens. Halfway again, it's 64 lumens. When you got to 100 miles from the moon, it's something like 10 million lumens, which would melt your face. Okay. So the inverse square law of light, which all science uses, is wrong. I assume you think we went to the moon, and this dusty, dirty ball.
We went 9 times.
This dusty, dirty ball is bright enough to look like this and so I can read by it. He's in the daylight on the moon, and the light that's bouncing off of here is bright enough to read by 238,000 miles away. That's insanity.
Can I make a point real quick?
Yeah, please do.
Just from my understanding from photography. So in this case with light, usually the moon does look a little brighter here when you point it out straight directly with a camera. But if you start fixing the aperture and the, what was the other?
Oh, you can take the aperture down. I'm saying that it's casting a shadow on the ground. It's bright enough to read by. That's a lot of light. That's a good amount of light. Right, but try to take a rock and shine light on it and then read from that reflected light off the rock. You can't.
Understandably, but I mean, going based off what the sun is, I mean, that's a way more powerful source of light.
I got you. Let's move on to another. Continuing.
Can I make a point?
Yeah, absolutely, 100%.
About the moon. One of the reasons why it even appears so bright is because it has no atmosphere. It has no clouds. Has no gases. There's nothing there to absorb the light or refract the light. It's just reflected light coming straight to the Earth.
So why do planets look brighter than the moon when they have an atmosphere?
In terms of the starlight that we see from here?
Yeah, like when you look at Venus, it's brighter than any star in the sky, and it's not a star. So they say. It used to be called a wandering star. And why is that brighter than any star? Way brighter than the moon if it has a really soupy atmosphere. What's we making that light reflect brighter than the moon from a farther distance? Hold on. Yeah. Let him answer.
You can see it. You're assuming it's brighter than the moon.
No, look at it. It's brighter than the moon. Okay. So we'll agree to disagree there. Let's talk about going back to Aristophanes 2,000 years ago. That's the story we've been told. All of our history before 1900 is a complete and total lie. I don't know if you guys have ever looked into Taria. You should. It was an advanced civilization here before us. All of our history is a lie. All of the world's fairs are a lie. Our Capitol building was built before we even got here. I interviewed this woman, 102 years old, back in February of 2020, and she had gone to the World's Fairs, and I was talking to her about it. And she had such a great memory. I asked her what she was taught in elementary school about the Earth, never mentioning flat Earth. And she looked at me, she said, they taught me the Earth was flat. 1920s, here in America, in public schools. She went to a school in Hamden, Connecticut. And then we did more research and we found other people. It says all the way up through the 1930s in other countries, they were teaching flat Earth. Then we found newspaper articles from the the New York Journal, which is now the New York Times, persecuting teachers in the 1920s for trying to teach heliocentrism. This was a takeover that happened less than 100 years ago. Okay. Everyone knew the Earth was flat. So
no, they didn't.
No, well,
just because they were teaching it, it's like saying, well, just because they were teaching ignorance 100 years ago doesn't mean that the ignorance was somehow truth.
Right. So do you know how fast the Earth is spinning? Your Earth?
Why don't you tell me, David?
Well, you're the one defending the globe. Do you know how fast it's spinning? Because I didn't when I defended the globe.
I know that it's I know your argument. I know that you reject that we're traveling through space. You reject that we're going around the sun. You reject that the Earth is rotating and that there's these 4 different speeds that are all happening simultaneously, and therefore we shouldn't be able to stick to the surface of the Earth, or there shouldn't be flat surfaces to lakes and oceans. Yes, I understand your argument. I understand ultimately your point. Ultimately, your point is the reason why everyone's lying. Everyone's lying to us is because it's taking us away from God. And it's taking us away from our uniqueness and, our specially created status in the cosmos. So in order to make ourselves feel special again, we need to reject all the discoveries that science has uncovered about just how big and gigantic and magnificent the universe is. You need to make it small so that we're important again.
Are you done?
Yeah.
Yeah, that's not the case at all. So we're spinning at 1,000 miles an hour, orbiting at 66,000 miles an hour, chasing the sun at 500,000 miles an hour. And just to give you an idea of how fast 66,000 miles an hour is, here's the hypersonic sled. It's going by at Mach 8.6, right? You have to believe that we're orbiting, watch it again, we're orbiting the sun 10 times faster than that. And we're chasing the sun at 100 or 90 times faster than that. Okay. And we don't feel any of that. These crazy motions are going on, curves, speeding up and slowing down, changing direction, which is acceleration. You have to believe that's going on. You have to believe that when you watch the sunset, that it's not going down, that you're falling over backwards, which is making the sun appear to go down. So I'm going to finish my point. Now I'll let you talk as long as you like.
Yes.
So I got my drone up. It's below freezing, super clear day. And I watched the sun. It went down, 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 down in 5 minutes. And if the Earth was spinning, it should just keep on going. But it didn't. It went down, 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 down. And then it stopped right here. And it just sat here. This is sped up 2,500%. And it sat there for 10 minutes. My friends at the beach started shaking. They said they saw the sun set from the bottom up 10 minutes earlier, but I didn't. I watched it fade into the thickness of the atmosphere where its light could no longer push through the soup. Now, this may be in focus. It may not be in focus. It may just be the atmosphere. I don't care. The fact that it didn't go down is what the issue is. It went down, it stopped, and it faded away.
And this is a video that you
I filmed this 7 different times. Yes.
Well, then explain to me how your flat Earth explains the disappearance.
Well,
if it's not going to go down below the horizon, then according to you, where did it go?
Thanks for asking. In this case, I could see it before the atmosphere became what I call the atmospheric deck of opacity. So let me explain what the atmospheric deck of opacity is. The atmospheric deck of opacity is as clouds, or even on a cloudless day, everything compresses into the horizon. And as the sun goes away, it's not dropping below these clouds. It's just going beyond them. And this bottom deck is the atmospheric deck of opacity. And then it stops. So I have a quick thing. Don't interrupt me going through this, and then you can talk as long as you like. Here's an example that I did. This line is level, and you guys can see that it's level. It's above my counter, which is just dark here. And I'm moving the sun along the line, and we're watching it from a celestial point of view, a raised point of view at the same height as the sun. And we can see that it's going in a straight line. This here can be mountains, trees, cloud deck, whatever you want it to be, but I'm showing you that it's opaque and we didn't go below it. Now I have a camera on the other side from a terrestrial point of view, watching that go away. This is the same thing. Now I showed you this first. I said, is this line level? You would say, no, it's going down. And I would say, is this sun thing going below this, which is at your eye level? And you would say, of course it is. Well, it's not. Okay. This is due to perspective. Now look at the line. I zoomed in. It looks like it's going straight down. Okay. And this is the sun just going away through this deck of opacity. Now let's take a look at a real sunset. Now you would think that this is the horizon, but the horizon is kind of above there. The atmospheric deck of opacity is right there. If I zoomed out, the distance between this horizon and this deck of opacity would compress together and you would not see it. Okay. I am showing you an example of a sun going away from me and going down and disappearing just like that. As it goes away, it sets due to atmospheric opacity.
So why did it stop moving?
It didn't stop moving. It just went away. Where did it stop moving?
No, you said it just sat there for 10 minutes without moving.
Right. So understand what you're seeing here. When it's going away, that deck of opacity, it just goes beyond it. I got out on such a clear day. That's why I said it has to be below freezing. It has to be super clear. So there's no atmospheric moisture. And it never goes beyond that deck of opacity. It just goes until its light can't push anymore. This is a much closer sunset. Here's a sunset filmed by a guy in Afghanistan, super clear, super dry, no clouds, no humidity. And the sun just faded away. It just went away. It got smaller because it's getting weaker. Right. And its light can't push through and it just keeps on going until eventually it disappears.
So real quick thing. So how will you explain like being at daytime here now, right now where we're in California, and being at nighttime, I think like in Australia or Tokyo right now, like Japan,
Yeah.
like there's two different things going on.
Can I address that?
Yeah, go for it.
Good.
You know, if you look at his Flat Earth app, and you look at, you know, the little, you know, model he has on there, basically the sun is a spotlight. That's basically what it is. It's a spotlight. And so the area,
it's a local light, light.
Well, here's the problem. If that were actually how things really were, you'd even be able to see the sun from the dark side. Because if you've ever been in a really dark theater, if you've been in a dark theater and there's a spotlight that's on the stage, the audience is in the dark. They can see the light coming from that spotlight and illuminating the stage. So if flat earth were really true, anyone in the dark could still see the sun illuminating the part of the earth they're not currently on. Everyone in the dark would still see the sun spotlighting a different part of the earth. It will be observable by everybody.
So I'm sorry that you can't. So I'm sorry that you can't understand that on an Earth with an atmosphere, where an atmosphere becomes opaque over distance, that once it goes beyond it, you can't see it. Its light can no longer go there. A spotlight on a stage is way different than the sun moving across the Earth through an atmosphere that has density. Is there a difference in air in the density of the air from the back of the theater to the front of the theater, or from the front of the theater to the stage? No, it's the same amount. But if you're looking over 10, 20, 30, 50, 100, 200 miles, yes, the density is what creates that density. It's like looking through a pane of glass, no problem. 2 panes of glass, no problem. 50 panes of glass, you're not going to see all the way through it. So as you look across the atmosphere, it becomes more and more opaque, and that opaqueness all gets pushed into the horizon. You need to understand perspective. You're shaking your head, but I just proved to you that this happens, and you use an example of a spotlight in the theater. I think we should move on.
Can you bring up that map real fast? The map that you were showing
me of like not understanding what he's trying to teach here.
Well, you're not understanding it, because when you go beyond the atmospheric deck of opacity, you can't, even with the telescope, you couldn't bring it back into zoom. You couldn't zoom it back in.
I never once said that the density of the atmosphere can't alter light. I've never ever said that that's not true. That is true.
But you use the example of a theater.
I'm not disagreeing with that. What I'm saying is that just like your analogy, just like you're zooming in with a telephoto lens, and on a boat and saying, well, that's the reason, why it looks like it disappears because of the limits of human vision. And that's not equivalent to actually disappearing over the horizon. Same thing's true when you've got low level clouds or you have a higher density for whatever reason closer to the surface, where the sun looks like it's disappearing before it actually hits the horizon. You're equating that disappearance, that early disappearance of the sun because of that higher density of atmospheric particles, smoke, dust, et cetera, whatever it is, getting in the way between your eyes and the sun. You're taking that to then mean that it doesn't ultimately go below the horizon.
So real quick, David, can you explain what's happening on the map in terms of like the placement of continents and just for the people listening so they can get a visual? Like what are we looking at in terms of placement and I really don't see Antarctica around there.
Yeah, because Antarctica doesn't exist. We'll get into that in a moment. Okay. Antarctica is the shoreline of the world pond. And if you want to just look up the Gleason's map, that's essentially the best map that we have for the flat Earth. If you watch this, the sky is the perfect clock. And the sun goes around once every 24 hours. The sun is the hour hand of the clock. Wherever the sun is, it's noon. So right here on the map, it's noon in Eastern Africa. And now it's noon in Central Africa. And it goes on and on. So the sun keeps track of the hours and the days. And right now you don't see the moon because I think there's a new moon. But if I speed it up, the sun, excuse me, the sun laps the moon once every 28 days. Okay. So as the sun starts passing the moon, you'll get a waxing crescent and the moon will start trailing behind. Its phase will get bigger. The moon keeps track of the weeks and the moons. There used to be 13 moons of 28 days, but now they've hijacked our calendar. So the moon keeps track of the weeks and the months. And then the stars keep track of the seasons. The stars are spinning the same way, the fixed stars, that is, not the wandering stars. And they're going slightly faster than the sun, right? The sun's going it's going faster than the moon, laps it every 28 days. The stars only lap the sun once a year. Mm-hmm. So the sun will hang out in a constellation and the next one will creep up and catch up to it. So the sun will hang out in each constellation for about a month. And that's why you can say the sun is in Capricorn or Cancer or whatever.
Is it possible to pause this?
Pause the video?
Can you pause it, David?
Yeah.
No, put the constellations back up. Yeah.
They're up.
All right. So according to Flat Earth, if I have somebody, first of all, this map is ridiculous. Imagine trying to imagine deflating a basketball and then trying to take the whole entire surface of the basketball and convert it to a two-dimensional flat image like this. It's ridiculous.
Imagine trying to take a flat image like this and wrap it around a basketball.
The continents are grossly not the right shape. But here's my point. So you got somebody at the tip of Africa, and you got another person that's at the tip of South America, and you've got somebody else that's down there in the southern part of Australia. So now, if I have them all turn their back, so their back's facing north, according to your model, they should all see different constellations. They should see a different part 100%. Of the sky, but they don't. They all see the same southern sky.
All right, I'm going to explain this perfectly well for you. And I don't know if you'll understand it, but it's very, very simple. Okay, so let's just take opposite ends. You got someone in Santiago and you have somebody in Australia. They're on opposite ends of the flat Earth. Right. So someone in Santiago has got their back to the north. So they're facing south. That's very good that you understand that. And they're looking down. So you see my mouse. And let's say my mouse is star XYZ, Southern Cross, whatever it is. Okay. So here, I'll do it up here. Someone in Australia at midnight, because it's midnight for them in Australia, because the sun's over here. It's noon here. So they're looking up and they see my mouse star. And we call that the mouse star. Right. It's midnight for them. 12 hours later, well, the guy in Sydney, in Santiago, he looks up. He can't see my mouse star because it's over here. It's near Australia. He's looking up and sees the sun. He doesn't see any stars. 12 hours later, the stars have rotated around. It's now midnight over here, and here's my mouse star. This guy in Australia, he looks up and he sees the sun. Okay. Same guy in Australia. In Australia, let's do it again. It's midnight. He sees my mouse star. 6 hours later, it's midnight over in Africa. He looks up. He sees my mouse star. 6 hours later, it's midnight in Santiago. He looks up. He sees my mouse star. 6 hours later, it's midnight in Hawaii. He looks up. Well, not whatever. I don't know if Hawaii is far enough south to see it, but that's how it works. They don't see them at the same time. You're watching hold on, I'm almost done, like 30 seconds. What you are watching are propaganda videos that are fed to you when you search flat earth, when you search star rotation, whatever. These are fed to you by the trolls that are promoted by Google. So I just 100% showed you how you see the same stars from 3 different points on the earth, and you're shaking your head no.
So real quick, for my understanding, so this is just what I understood from this. So flat earth is stationary, and the constellations and the stars, the everything above us is moving around the flat earth
in the earth system. Correct.
Okay.
Basically, his model is that we're in a pond surrounded by ice. The highest walls of this ice contain the oceans, which is the pond, and we're
not
all
a wall. Go ahead.
Tiny islands. And there's a big giant snow globe dome over us. And
I don't believe that.
Well, I've that's basically what you say. You say essentially that those objects.
I don't know what shape the sky is.
You don't even think it's physical. You think the stars aren't physical.
I don't know what it is. I don't know. Do you know what it is?
Yeah, we do.
Because in your model, you believe that we live in this high pressure system next to a space vacuum. Well, physics shows us that you need a container to have pressure. You can't have air pressure without a container. And I don't know. So I have some sort of dome on us. Something's up there. If you
reject gravity, then yes, everything goes flying away. This model rejects everything science has ever discovered about our physical world. This model has to reject physics. It has to reject chemistry. It has to reject geology.
What geology?
Well, how do earthquakes happen? I mean, we know how they happen, but how does it happen on a flat earth?
They can work on a flat earth and a ball earth. It works the same way.
So
the continents aren't. So hang on, unless you're not done. Are you done?
I was asking, are continents moving in a flat earth?
No.
Then you're rejecting geology.
I'm rejecting pseudo geology. So you believe we went to the moon a bunch of times and they brought back rocks?
Left stuff on the moon. We left stuff on the moon that you could see if you have a good enough telescope.
Nobody can see it. No one's ever seen it. Okay. So the rock that we gave to Holland or whatever, they decided to insure it, and the insurance company tested it and it was petrified wood. Okay. So they're lying about everything. That's a fact. Look it up. Moon rock, petrified wood. Just look it up. Everyone, Google it. Don't listen to me. Don't listen to him. Just Google moon rock, petrified wood. It's not even a conspiracy theory. It's a fact.
I mean, the point I'm trying to make here is we understand plate tectonics. We understand what's causing the continents to move, why the Earth's crust is broken up into plates. We understand all of this. We understand why volcanoes erupt. We understand how lava and magma work.
We do.
Right? And so, again, if you're going to say the continents don't move, if you're saying there is no plate tectonic motion, you are then rejecting all the implications from all those things you just admitted geology knows.
So hang on. I admitted nothing. And every single thing that you just said is you offered no facts with it. You say, we know how lava works. Well, you believe that lava comes from the center of the earth and creates cone-shaped mountains.
You didn't say it came from the center.
Can I finish?
That's not true.
So wherever it comes from, it's coming from
the mantle.
Do you believe that there's mountains that spew lava out of the top?
Yeah, they're called volcanoes.
Okay, find me one. You've never seen one. You've only seen them in movies. Okay, and
you've never been to Hawaii, obviously.
Find me a mountain, a cone-shaped mountain spewing lava out of the top. Hold on, I am not done talking. I am not done talking.
Okay.
Yeah, let's try not to interrupt each other, guys.
Jeez.
You have never seen a cone-shaped mountain. The only thing, okay, can you turn off your video? Because you're shaking your head while I'm talking is super annoying. right? When you've never seen a cone-shaped mountain spewing lava out except in movies. Sometimes the news will show you something, but occasionally they'll pull back and you realize, oh, that's only 20 feet tall. What lava is lava tubes. Lava tubes are where the electricity that is going through the earth, the earth is like a big capacitor, and I'll show you that in a second. And the lava tubes happen where the electricity melts the rocks. So we have some rocks here, I'm putting in this ceramic thing, putting electricity through it, and it turns it into lava. That's what creates lava. Lava tubes are all over Hawaii, and occasionally they break the surface. And when they break the surface, they bubble up and they get higher and higher and higher, and they make a cone-shaped hill 10, 20 feet high. And the news will shoot it and make it look like a giant mountain because they're shooting it really close, right? There's never been a cone-shaped mountain spewing lava. Now you could say Mount St. Helen. No lava came out of Mount St. Helen. That was an explosion. Okay. Don't know what it was.
Okay. David, can I stop you right there for a second? So when we analyze what Mount St. Helens is made out of, or Mount Shasta, they're made out of layer after layer after layer of lava rock. So even if you weren't there for the eruption 13,000 years ago or 28,000 years ago or 80,000 years ago, the evidence that it erupted and helped contribute to that cone-shaped gigantic mountain, the evidence is in the mountain.
Yeah, I reject that 100%. We could agree to disagree on that. So here's the thing. You believe in gravity when your high priest of scientism, Neil deGrasse Tyson, says they don't know what gravity is. As a matter of fact, science, pseudoscience, doesn't know what gravity is so much. It's such a theory that they have to make up 96% of it being dark matter and dark energy. They only know that 4% of it is due to mass, of the mass of the physical mass that we can see. The rest is made up nonsense.
Can I
I'm not done. I'm not done. So what is
throw a lot of things out? You don't like stand.
All right. Well, you know what? I'll stop. Go ahead. I'll give you a break. Go ahead.
When you're talking about we don't know anything about gravity, Einstein explained what gravity is.
So which gravity do you like? The Einsteinian gravity or the Newtonian gravity?
Well, Newtonian gravity, Einstein took that to the next level. Newton didn't know actually what gravity was. All Newton did was explain its effects. Just as when they first came up with continental drift theory, when Wegener came up with continental drift, he didn't know what made the continents move. He had the evidence that they had moved. He didn't know what made them move. It wasn't until plate tectonics that we had seafloor spreading, that we had the mechanism for what made the continents move. Wegener had proved they'd moved, but he didn't know what made them move. Newton proved what gravity's effects are. Newton didn't know what gravity was. Einstein answered that question. So Einstein's discovery of what gravity actually is didn't disprove Newton. It added to what we know about gravity. It was an additive effect. It was not subtractive.
Yeah. So you're referring to these 6 or 5 Freemasons that you've never met or seen, and that the people that told us about, all the nonsense in the world are the same ones that told us about this. This is put in his story books, right? Which are, you can't confirm any of that. So I'm disregarding everything. So what is gravity? Well, gravity could never be proven, this mass, causing gravity. So what is gravity? Well, the earth has a testable, scientifically provable, measurable negative charge to it. The sky has a positive charge to it. And as you lift up off the earth, there's voltage in the air. There's a lot of voltage. And that's been proven with free energy technology. Tesla proved it. So the sun and the moon are the anode and the cathode of the battery system. The salt water carries the current of the earth. Electricity and magnetism are the only true forces on this earth, and the land is a salt bridge. It's a giant battery system, and the earth has capacitors, and Hawaii has lots of capacitors in them, and the energy going through creates these lava tubes. That is testably, provably true, where this whole theory of what's underneath the earth is nonsense, because when you look at the earth, the deepest hole ever dug is short of 8 miles. That's like drilling halfway through the skin of an apple. And while they were doing it, they were wrong every step of the way. They were wrong. The ground penetrating radar said, no more rocks, no more water. They hit rocks, they hit water. Okay. Then they hit an impenetrable barrier for whatever reason. They couldn't get any deeper. but somehow they knew the next 4,000 miles what it is. This is a meme that you were taught to defend.
Can I address that?
All you.
That's not a meme. Reason why we know about the interior of the Earth is because when there's earthquakes, it creates seismic waves, infrared sound that travels through the different layers. And because of the different densities and temperatures and pressures of those layers, it refracts those seismic waves at different angles. And when they exit the other side of the planet, we can actually see, because of that refraction, how thick a particular layer is or where that layer is located.
Yeah.
That's how we're able to know. It's called indirect evidence. It means you're not seeing with your own eye, but you have evidence based on the properties of sound waves traveling through solids and liquids that lets you know what is going on. It's like taking an x-ray. You didn't go inside the body and see the bones for yourself, but it's indirect evidence.
But you saw the x-ray. Did you see the people that measured all of these sound waves? You know who measured them? These people, the people that use the flat earth map as their logo, sticking it in our face.
That's not
you
science.
Do not measure these waves. Yes, sound vibration waves go through the flat earth. On a spinning ball in a space vacuum, it's insanity, right? There's been tsunamis that made no sense on a globe, but make perfect sense on a flat earth.
Why?
Because the tsunami wave reaches some land. Like, how did it get there before it got over here? Then you look on a flat earth map. Speaking of the map, let's just get into that a little bit. There's NASA is in charge of all flight routes. Okay. NASA's in charge. All international flight routes. NASA is in charge. They're in charge of radar.
We just have to accept your word for it.
You can go look it up yourself. They're in charge of GPS also, which is a whole nother thing. And there's no GPS in the open ocean. There's no GPS. If the satellites were flying all over the earth.
You're inaccurate, because in 2019, they launched new satellites that are able to connect directly with the planes when they're over the seas with their transponders. So the pilot doesn't have to check in every 10 or 15 minutes.
Cool story.
And let them know. It's not a cool story.
It's a cool story, bro.
You got these silly little special effects. You know what? You diminish like the importance of this conversation by doing these ridiculous little visual effects.
Yeah. I put on the glasses because
there's not one plane right now over the ocean that we don't know where it's exactly at because of this new technology. But you reject that there's even these new satellites out there communicating with the transponder in real time now.
Yes, I do reject it.
Every 10 or 15 minutes.
I do reject it. I do reject it because when you're on a flight, are you done?
Yeah.
When you're on a flight, and especially in the southern oceans, once you're 100 miles or so offshore, you disappear until you're 100 miles from your destination.
You used to.
No, still.
No.
Okay. Yeah. And so, all right.
I'm conceding you're right. I'm conceding you're right about that before.
I'm going to show you that they're lying about where the plane is, and we've proven it.
Oh.
Do you want to see the proof, or you want to just shake your head more?
It's not going to be proof. It's just going to be whatever you can. It's not going to be visual proof for anything.
So let's just talk about plane routes for a second. This is the plane route from Santiago to Eastern Australia. You want to go to Western Australia, you got to go all the way up. Remember this route, all the way over to the Far East, Singapore, and down. Why don't they just cut across the bottom of the globe, right? Why don't they just cut right across there? And the answer is because that's not how they go. So remember this, all the way up, all the way over, and then down.
So he's got a visual
on a flat Earth map. I'm still talking. Sorry. I'm sorry. Did I stumble? And you go all the way up across Far East, Singapore, Western Australia. It's a straight line. Airplanes fly straight and level over the Earth plane.
No, they don't.
Oh, they curve. They curve over the plane, right?
Exactly, because planes fly in 3 dimensions, not 2.
Right. So when the plane's flying for an hour, how does it know not to go 30 miles higher into the sky? How does it know to curve down? Gravity holding on to the big rope as it's going? Is it trying to fly away?
No, we have instrumentation that lets them know how far above the surface they are, and it maintains that elevation. It's not that hard.
So it maintains the elevation above the Earth. So it's ignoring the topography below them. It just maintains the elevation, the mean elevation.
Yeah,
that's not how planes work. Sorry, we can agree to disagree on that.
So real quick here, guys. So David, who benefits from all this? Like from lying to us?
Why everyone's lying?
Yeah, because
let's go with that.
What they don't want you to know is what this place is, what this world is.
Who's they?
Who are they?
Yeah, who's they?
Yeah, these people, the United Nations, the Council of Foreign Relations, the Bilderberg Group. These are the people that run the world. The Trilateral Commission. These are the people that run the world. This isn't a conspiracy theory.
Very QAnonish.
How does this sound QAnonish when this is known facts?
They believe in a global conspiracy of elites that are.
No, this is not a conspiracy.
And they're killing babies and drinking their blood.
Bring up all the stuff that I'm not talking about.
No, I'm
showing you facts.
This is ridiculous as that.
I mean, can you build on that, David, just so people can understand what we're seeing here?
So there is a global power that runs this world. There's only a few corporations, and there's the royal family. Excuse me. The royal families, the banking families, they are trying to rule the world. So back to your question, this world is not what they have led us to believe. They don't want you to know that your thoughts create your reality. They don't want you to know, and everyone listening, the world that you live in, your life is the way that you think. Your life, everything you have in your life is the way that you think. You've brought everything that you have into your life through the power of your magnetic thought. Okay. They don't want you to know that's the case. So what they do is they keep you in fear because fear inhibits thought. They put you in a cage and told you that's all there is. There's nothing more but this cave, whatever you want to call it.
Flat Earth is the cage. Flat Earth is the cage. We're literally
absolutely not. I'm not done talking. Thank you. All right. They put you on a ball, just like in the Truman Show. There's nothing else to discover, Truman. He wanted to be an explorer, right? They've limited your thought, right? If you want to look at what the Earth could be, maybe the Japanese knew something when they made this map with all these other continents out here. You should read the Iron Republic, where it's a story of people that left in the 1600s to go to the outside. There's no wall. Okay, that's Game of Thrones you're talking about. Okay, I'm not talking about the Game of Thrones. I'm talking about the shoreline of the container that holds our water, right? Water needs a container. Antarctica is the high.
Isn't that true though? I mean,
is the shoreline of a lake a wall? Is the shoreline of a lake a wall?
If you go underwater and it keeps going down, it's a wall.
It's a cliff. It's the edge of it's a container.
You're saying
it's a container. There's no other side. A wall says there's another side to the wall.
Only the part that's above water counts. So all that material that's going down to actually make the pool doesn't count.
It's just the depression. We live in the Antarctic basin. Okay, that's where we live. The water is contained by the land that surrounds us. Antarctica is likely bigger than all of the continents and all of the oceans combined. What's beyond there is a great question. It's off limits. It's the longest treaty that has ever lasted. In 1959, no one could go to Antarctica because they have to protect the penguins. And it's the longest treaty that's ever lasted. And nobody is allowed to go there until the year 2041.
That's not true.
I didn't hear a word you're saying. Sorry, I was talking.
Just a couple of more things. I do know that from what I've read is that I think Antarctica does have restricted airspace to an extent. I think it's only for like military use.
It doesn't have restricted airspace. There's nothing restricted about it. If a private citizen wants to go there in their own yacht and their own plane, they can go.
There
are no restrictions.
That's 100% false.
The actual treaty is not true.
So I agree with you. Don't believe me and don't believe you. Don't believe anything, but go do the research. But we already did the research for you, and we just show you where you go. If you click the question mark on the Flat Earth, Sun, Moon, and Zodiac Clock app, and you click, what about Antarctica? Where is Antarctica? Where is it?
How come no flat earther has ever had the balls to actually go to the shoreline of the big pool and see for themselves what's going on there? Like, is someone
I'm going to tell you why. I'm going to tell you why. So in the app, there's a video called "Sorry, Antarctica is Closed." We did all the research for you. We show you all of the documents. We've made the phone calls, and we've shown you examples of what happens when somebody tries to independently go to Antarctica. They are stopped by force, and you're not allowed to go there. And the way they do this is if I go to the pictures, and let that load for a second. There's the crown owns all of the islands that surround our world. These are all controlled by the crown, and there's military bases on each one of them, including the Falkland Islands. Wonder what that war was about. Okay, so this is how they stop you. People have gone, they've been threatened to be sunk, they've been turned around, sent back to their own countries that gave them permission to go in the first place, and then they were put in jail. Okay,
how come no one ever videotaped this?
There's tons of stuff out there.
Videotape,
right?
soldiers
here's the
stopping
thing.
you.
Here's the thing. Just look it up. You look it up. I think his name is Shackleton or something. Don't quote me on that. I don't know his name. But where was I going with that? I had a great point. It was going to be a great closing point. You can't go to Antarctica, right? You can pay $10, $30, $40, $50,000 to go for a couple of days. They take you right here to this giant peninsula. They show you some icebergs, they show you some penguins, and then they kick you out. You're not allowed to independently explore out here. And if you go to that Antarctica button in the app, it'll show you all of the people that have lied that they've crossed Antarctica, and we show you their actual route. Okay. So southern circumnavigation has never happened, and that's because the earth is flat. Well, East and West have happened billions of times.
I will respectfully disagree. You need the southern hemisphere to disappear in order for your flat earth to even be a possibility. If the southern hemisphere didn't exist, you would love it because it would get rid of a bunch of the problems that make flat earth impossible. But the southern hemisphere...
I don't know what you're talking about.
How do you get the aurora in the southern hemisphere?
There's electromagnetic fields all over the place.
In the north. Well, there's always a positive and negative anoid to a magnetic field.
The sky has... When you're done, I'll answer the question when you're ready.
I'm just saying there, you're going to concede that there are two different charges on either end of a magnet. Positive charge and a negative charge. You can do this with simple magnets. You can put them together. Positive repels positive, negative repels negative. Yeah. So
and
there's
also
a positive side of the earth and a negative side to the earth.
You believe that, right? But we can testably measure the voltage of the ground, the negative charge of the ground. And I'm going to finish what I'm saying. And the positive charge of the sky. And that's what's causing all of these phenomena, period.
There's no positive charge in the earth. It's just negative.
Well, you're wrong. You're wrong.
No, I'm asking you.
So I have a way. I have a way to prove that the earth is flat or globe. Very simple. And it would be very simple. The last person to try to circumnavigate Antarctica was Captain Cook. He went over 60,000 miles. It took him 3.5 years, and that makes no sense on a globe Earth. So here's what you do: we get a plane, we go to Antarctica, 2 planes, and one plane flies this way about 1,000 feet off the ground, just follows the shoreline, and the other one goes this way, and they say this is 13,000 miles. So 6,500 miles later, both planes should meet over here, about 9 hours, whatever it takes. And that would prove the earth is a globe, but it's never going to happen because 1, they won't let you. And 2, Captain Cook tried it, I think 3 times, went over 60 to 80,000 miles. Okay. No one's ever done it.
There are thousands of polar flights every year.
No, there's not. There's none.
Yeah. The flat earth. It's funny when you look at the shape of the continents, how you have to take a 3-dimensional surface and try to break it and fit it into 2-dimensional surface. You take something like Australia and like Russia. Russia is like 6,000 miles long, and Australia is like 2,500 miles long. But on their map, Australia is as big as Russia, and it's clearly not.
Absolutely not. You're wrong. And I said at the beginning that our map isn't perfect, but it is the best map that we have, and it is the one that's used for navigation. There's no pilot that takes a globe into the cockpit with him and uses it. The distances from South America to Africa make absolutely no sense whatsoever when you actually look at them. There's no flights that go from, where is it? Here we go. That go from Buenos Aires to Cape Town, right? Buenos Aires to Cape Town, right? On a globe should be 4,276 miles. Should take about 8 hours. Okay, bam, straight across. But that's not how they go. They go all the way up to Amsterdam and all the way over, this is the route that they take. But if you look at that on a globe, they go from here up over the top of the ball, back to the backside, and then back down, which is ridiculous. Okay. That's because it's following a flat Earth map, right? If you look at the flight route from Wuhan to Colombia, I think there was an emergency landing on this one right about here near Hawaii. The plane needed to land. Where would you land? Hawaii. Maybe you double back, maybe you go forward, but why the hell would you go to Alaska? And the answer is because this is the real route that they took. Here, Alaska. Bam. Hawaii is all the way out here. This is the route that they took. So we had Max Egan. He took a flight. He's not a flat earther. He's a globe earther. And he took the flight from Santiago to Australia. And his map on his seat and the radar, we were tracking him live. We did a 14-hour live stream, and it showed him going south, right? And then southeast and going over. But he took compass readings, and on his compass readings, it was northwest, 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 west just for a second, and then southwest, 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 south, right? Which makes no sense on a globe, but we plotted it, and look, it's a straight line. It's a straight line. There's 16 emergency landings that have proven flat Earth. They always land in a crazy spot on the globe, but if you take a line from the destination to the origin to the destination, they always land on that line on a flat map. 16 times it's happened, okay? I don't know how many more times it needs to happen to prove to people that the globe map is ridiculous. They wrap the flat Earth around the globe. Google Earth, what was it, a decade ago or no, maybe I'm not sure how long, used to be flat, and then they changed it to globe. GPS is a closed source code. Why is GPS closed source code? Because they don't want you to see the bullshit that where they wrap it around a globe. It's all done in Photoshop.
So now to finish this off, Nanoski, do you want to finish the last point on this?
I mean, when you analyze like how much time he had to talk versus me, it's probably going to be like 60-30. It's an infomercial for his app.
My app is just a way to get by the censorship. That's all.
This is what you do. You throw a lot of stuff out so no one can think about any one particular thing. You just throw out, and just, and then you can't like.
Which one would you like to discuss?
Well,
I'll discuss one. I like talking one point at a time.
Let's give him a second.
No, I mean, you've already like made all your points. My point,
I got more,
is that you're a science denier. That's
science. What science am I denying?
All of it.
All science. Those are just words. You have to come up with what science.
I'll say this: you're a cherry picking science denier. You pick what confirmation bias. You pick what confirms what you want to believe, and then you pretend like you just say, "I'm going to disagree. I'm going to reject that," even though it's also factual. So you cherry pick.
That's not true. False.
The very again. I'm going to go back to light because the properties of light let us know how big the universe is. The universe is gigantic.
Right.
The universe is gigantic, and he wants it to be small.
And
he wants it to be a little dome, with these little.
I don't want it to be anything
in the dome. That's what you're saying it is.
I'm not saying how big it is. I'm saying I think the Earth is an extended plane. Don't tell me I want it to be small. I think it's massive. I think we have way more options than they want us to believe on this little globe.
Science proves that the universe
what
is
science?
bigger than just this little globe.
You keep saying that. What science?
Well, let him make his point across. Go for Nanoski.
Your problem with science is that it's proven the universe is gigantic, and you don't want it to be gigantic. You want it to be small. You want us to be locked in it. We can't get over to the edge of the pole because people are going to shoot us and turn us away.
Fact.
So we're stuck. We're stuck in this tiny little dome, little snow globe.
It's bigger than that. They're just not letting us near the edge.
Behind you. It's literally behind you. It's a snow globe. You've got a snow globe. And
I'm showing you a artistic representation.
It's a pond in a snow globe. That's your model. And it rejects everything science has ever discovered about the universe. So
what science?
Anyone listening to this, your choice is reject everything science has ever learned about the universe and about atoms and about everything, every ology, geology.
Have you ever seen an atom?
Are you serious?
Have you ever seen an atom?
We can see them with tunneling electron microscopes using quantum physics. But I bet you reject
quantum physics. Yes.
Now, you do know, I'm going to say this for everyone out there. Science makes discoveries that are counterintuitive. That means that your senses are telling you one thing and reality is the opposite of what your senses are telling you. So for example, when you think you're touching something, you're not. All that you're feeling is the repulsion of electrons away from each other. If you could be the size of an electron, you would see that there was empty space between you and whatever you were touching. So touch is an illusion. All right, you're 99.99999% empty space. Atoms are mostly nothing. If you were to take all the emptiness of all the atoms that humans are made of, you could fit every human in a sugar cube.
I'd like to put my glasses on again, but I don't want to trigger you.
That's very counterintuitive. That's counterintuitive because you feel 100% real, but you're not. You can't trust your senses. What science is a lie detector. Who's the liar? The human mind. Your senses and your mind can convince you of all kinds of things being true. And then when science comes along and disproves one of these cherished notions like solidity or touching, people don't want to accept it.
Works on a flat earth also.
But that's not true because the implications of those discoveries in physics would make flat earth impossible. If you cherry pick the data, then you can make your flat earth work for you all you want.
False.
So we're going to start ending this now because we're at that time. But if you had the opportunity to go onto a space shuttle and you fucking went up out of the sky and you saw the earth and you saw what it was, would you change your mind?
If I could turn you into a butterfly, would you change your mind that you're not a human? I mean, that's a ridiculous question because no one has ever been up in a rocket ship. So yes is the answer, but it's a ridiculous thing because
it's a what if question. Happen. But it's a what if question. It's a hypothetical.
So if he was about real science and he had an opportunity to see for himself whether the world was round or really
absolutely, but nobody goes to space.
He's saying he wouldn't.
That's not what I'm saying.
Yeah,
you are very triggered. Okay, so let me finish up. Is you made your statement and now I'll make mine. I choose to use my God-given common sense and not trade it in for nonsense. I have senses that the creator gave me that I can use to see this world. I'm not trading it in for nonsense. And I don't let my mind be infected with cartoons because everything that you're talking about in space is a cartoon. Everything that you've been told about science, about space is unverifiable by you. Now, there are things that are verifiable, like the angular size of things. Okay. As something goes into the distance, will you agree that it gets smaller? Yes or no?
Yeah, that's why there are stars.
Okay.
There are
do you believe? Let me just make my point without you making a point in between. Let me make my point without you making a point in between. You believe that things get smaller into the distance. Okay. So as something goes away, it gets smaller. Well, its angular size will get to the point where you can't see it anymore. We can use science. We can use, perspective to tell us how far a penny needs to be where a human eye can't see it. I think it's like, 100 yards, 200 yards, whatever it is. Right. So we can look and we can prove that the sun, if it was 3 times as far as it is, we wouldn't be able to see it. Okay. But I'll make it 24 times as far. We wouldn't be able to see it. Well, Polaris, which is 46, 48 times bigger, well, then that would need to be 48 times farther. So if that would equal 6 light days. If Polaris was 6 light days away, it's scientifically provable its angular size would be too small to see. You can do the numbers yourself. I'm just jumping in a lot of things here, but figure it out yourself. It would be too small to see. But they tell us Polaris is 433 light years away. Well, we couldn't see it at 6 light hours away or 6 light days away. Give me a break. Pseudoscience. Guys, this was, I'd like to say it was fun, but it wasn't really that much fun. But I enjoyed talking to you. I think we've made our points. I don't think that you'll ever see the flat earth. If there was an opportunity to go into a rocket that goes into space, sure, I would take it. It's never going to happen. And the earth is flat. You just have to look into it and ask yourself, why is Google hiding it? Why are they showing you Bigfoot and aliens and all this stuff?
You believe in aliens.
I believe in extraterrestrials.
Oh, okay.
They come from the extra territory.
Oh,
the extra territory beyond in the outer space.
Oh, do they ever visit us?
This is the outer space.
Do they visit us?
Maybe. Absolutely. I don't know. Why not?
Oh, well, we can't visit them, apparently.
Well, okay, guys. It was an interesting conversation nonetheless. David, I still want to appreciate the time that you took to come on this and explain your points. I really do appreciate that. Thank you for that. And Nanoski, the same with you. There's nothing.
Thanks.
Honestly, I'm glad this happened because, again, at the end of the day, everybody has their own perspectives. And if we can have a conversation, whether we agree or disagree completely, it's something that somebody else is listening to and they can help make better decisions.
I appreciate that. And don't believe anything I say. Go verify it yourself. And if you can't verify it yourself, put it in the basket of I don't know.
Buy his app so he can make some more money off people who reject reality.
Don't buy my app. Don't buy my app.
But
just go find the information yourself. It's going to take you a lot of time, and $3 will save you all of that time. Don't buy the app. Just go read the reviews on the app. See what people are saying about it. Don't buy the app.
With that being said, I do agree with that. Everybody do your own research.
Yes, definitely do your own research.
You can find me at flatearthdave.com. All my links are there.
Thank you again for your time, David.
Thank you.
Man, this is a crazy conversation. But the part that trips me out is that I was watching this National Geographic video a couple of days ago, and it was showing that around 2% of the population in America is a flat Earth believer.
I think it's higher, actually.
Yeah, I'm starting to think it's higher too.
I mean, that's one of the reasons why I came on to do this. I saw, again, some of the podcasts and things that you did with other people in these other programs that he's been on. And that's his ultimate reason. His ultimate reason is science basically proves that we're small and that the universe is huge. And there's a lot of things we still don't know. Like when you brought up dark energy and dark matter, yes, it's true. Over 90% of the universe is made out of something we haven't figured out yet. But science doesn't make up something. We admit we don't know what dark energy is, and we don't know what dark matter is. And scientists around the world are trying to study it. They're trying to experiment on it. They're trying to figure out what it is so we can have a better understanding of the universe. Scientists don't put their head in the sand and go, oh, because we don't know what that is, we're just going to stop searching. We're going to stop thinking. Like science can admit when we still don't know something, when there's a mystery to be solved.
Right.
And he rejects that completely.
I know it's honestly a little scary.
I like that you asked that question at the end. If you have opportunity to go in a rocket or go into even a high elevation spy plane, goes to the very edge of the atmosphere, right? Mm-hmm. Like you don't even have to leave your little, snow globe and see for yourself, is the earth flat or is it curved? And again, if he was offered the opportunity, his first gut reaction was no. His first gut reaction was no. Like, you're not curious? You're not curious. You don't want to know.
like I said, it's like if you had the opportunity to disprove or make your point valid, I'll be the first one.
I would love to. I would love to go and if I went all the way up there and I was orbiting at the same distance the International Space Station's orbiting at, and I did not see curvature, I would come back to Earth and totally admit I'm totally wrong.
Yeah,
people that he said are lying, they are lying. I would admit it because the evidence would be there. He doesn't even want to see if the evidence is there. He just wants to keep on talking.
Honestly, it seems like even if that experience did happen, they'll still find a way to justify the fact that it's not. It's
they would be like,
augmented reality or something.
Yeah, there was a curving of the light and there was extreme refraction. I mean, if you really truly want to believe, you'll just convince yourself of the evidence not being there. That's just a sad condition of human beings. We're wishful thinkers. We really, really want to believe in a lot of things. We're actually born believers, right? So our brain is literally wired to just believe something first without proving it. Science goes against that. It's like, your senses are telling you this is true, but is it really true? And that's why we do experiments. That's why we collect data. That's why we try to reproduce the results from other scientists.
Yes, exactly.
Did our brain lie to us? Did my brain deceive me? Did my senses deceive me? Or did that actually happen? That's what I meant in the beginning. I said that science is a lie detector, and we are the ones lying to ourselves. The only way we know about real things going on around us is if we have verified them. And so a lot of the things that science verifies, people just don't want to accept the truth. because it's hard. I was like, all the technology you love in your life, all the things that are making your nice 21st century life possible, all of your appliances, your smartphones, your ability to get on a plane and go on a vacation, just all this technology around the world that just makes our lives so much more fun and so much more effective and so much more meaningful. You would have to reject every part of science that made that technology possible. That's what I don't get. I don't get, like, you're rejecting everything that's making this ability to connect on Zoom. This is possible because of science, not because we want it, not because we wished it into existence.
Right.
Yeah. I apologize if I got frustrated sometimes.
No, he got fired up. I could tell you were getting frustrated, and I was like, and then at some point he was like, "I'll end this," and I was like, "Oh shit."
I want to see. Can I show you something? It's just, I think this kind of really encapsulates, what I want people to kind of get, seeing the bigger picture.
Oh yeah, I see.
And something I tell my kids: science will tell you the truth even when you don't want to hear it. And so you got this kind of cartoon here. It makes the point. What would people prefer, comforting lies or unpleasant truths? Right. And most people line up for comforting lies. Things based on your own personal beliefs, based on your own personal opinions, based on your own personal hearsay, things that are subjective. Science tries to be objective, tries to prove things, right? Facts are true, whether you want to believe in them or not, right? You can't be like, the doctor told me I have cancer, I'm going to choose to believe I don't.
Yeah,
right. Of course. It's an unpleasant truth. No matter what you believe, the cancer's still going to be in you. You can't stop that. So that's my point I want to make. Science has made important contributions to our understanding of reality, all of reality, from inside your body down to the subatomic world to the largest stage, the entire universe, and the origin of the universe and the size and the expansion of the universe. Science has made important contributions to our understanding on all levels. And if you choose to reject all of that knowledge, you are rejecting reality. You're living in your own reality at that point. And you're free to embrace your comforting lies. But just because you can get on the computer and you can connect with like 5,000 other people who all believe the same lie you do, it's never going to make your lie the truth.
Yeah.
I think that's my point. The internet's made it easy for people who believe in a comforting lie to find others who believe in the same comforting lie. And they all can make each other feel good because they believe the same comforting lie.
Yeah, and that's what it is. It's about staying comfortable. And the moment you hear otherwise, you're in panic mode, it's full survival, trying to justify why your beliefs are the ones.
But see, here's the thing too, when the algorithms of these different social media platforms, so if I don't care what you're on, Twitter, YouTube, Facebook, Instagram, whatever it is, the algorithms that they have programmed into that software that makes those platforms run, it's meant to keep throwing things at you that you've been watching. So if you've been watching a bunch of flat earth stuff or a lot of conspiracy stuff, COVID-19 is not real. If you go into those rabbit holes, all those platforms are going to do is send you more of the same. And you're just going to go deeper and deeper and deeper into the rabbit hole until your brain is so fried, you can't get yourself back out.
Yeah. No, it's true. Yeah.
It's literally a black hole of misinformation. You're literally been sucked into a black hole of misinformation, and like a black hole, you aren't coming back out.
Yeah. No, it's interesting because I used to at some point go to YouTube and, like you said, go down rabbit holes of, I'm not gonna lie, I used to go and look at conspiracy videos and be like, all this stuff, right? And for a while, for a couple of months, I was eating all up. I was just like, no, they lied to us, all this stuff. But
well, you know what though? You know what? I think it's a hypothesis of mine. I don't know I don't know if this is certain or if it's true, but I have a hypothesis that because of our shutdown from COVID, so many people not going to work, so many more people staying at home, so many people staying away from other people, especially when it was like really at its worst. Yeah. I think people had so much extra time on their hands. They had so much more time to be online, so much more time to indulge in these rabbit holes. You saw a huge spike in conspiracy theories, huge spikes in things like we didn't go to the moon, huge spikes in flat earth, huge spikes in, the vaccines are fake. all this stuff, it really spiked. And I think part of it was because people just had more free time to be on the internet, to like watch these videos and follow these different people and just literally just bathe themselves in this stuff. Like just be saturated in it. And that's all you know at that point.
Like I mentioned earlier, that comfort that makes it reasonable for them to want to find something like that, you know?
Yeah. I mean, he was talking about, I think at the end there, he was talking about how the creator gave him his senses, right? So his belief is that God gave me the ability to see and so on. And science understands that when it comes to all the possible frequencies of light in the universe, the electromagnetic spectrum, the human eye literally sees like 0.00035% of all the light that is possible. So we're seeing less than 1% of all available light that exists in the universe. So if we only depended on our God-given eyesight, we would be literally blind to almost everything that happens in the universe. We would have no idea what's going on. We'd only be seeing that tiny little fraction of light that's vibrating at the right frequencies to be picked up by the cells at the back of our eye. So you're going to reject everything outside that narrow range. You're going to reject gamma rays. You're going to reject X-rays and infrared rays and TV, radio, and television waves. All things we utilize, by the way, on the lower end of the spectrum to be able to do this, to be able to have Wi-Fi, to be able to talk to each other on smartphones and not be plugged into a wall, to be wireless. Like you're rejecting the electromagnetic spectrum at that point. Like if you're going to reject the rest of it, then don't use your phone because you're being a hypocrite. Don't use technology. Don't use a computer. Go live in a cave somewhere and, you know, eat bugs. I mean, I'm just saying, if you're going to be true to your convictions, if you're going to be true to your convictions and not be a hypocrite, then you'd have to reject everything science has ever discovered that makes your tech possible. Jesus. You know, but he's throwing things out so fast. I don't have time to like, you know, and then when I would try to slow it down and try to explain like one particular, he just didn't want to like wait around for that because that requires too much thinking, you know.
And he wanted to change to another point. And,
always wanted to change to another point.
Yeah, it's like the moment it got to the point where the argument was kind of coming to its breaking point is when he's decided to kind of shift up to another. Yeah, man. I mean, I don't even know what to say anymore at this point.
Like I said, I apologize if I came across a little bit, you know, frustrated at times, but I seen his other presentations and his other, you know, things he had done online. And I just was not going to be that interview where he just got 90% of the time and did an infomercial for his app and, you know, had to like at some point just stop the situation and say, I'm going to make a valid point.
I'm glad that happened because from what I saw, he doesn't have many people confront what he's saying and really try to break it down.
That was my issue is I saw no confrontation, no pushback.
Yeah.
He was just allowed to like spew it. And, you know, a couple of times I said, we just have to take your word for it. You're saying something as though it's a fact, and we just got to take your word for it because you rejected any facts I've brought up. You just literally say, I don't accept it. You literally just said, I don't accept it. And then you wanted to move on.
Yeah. Now, well, either way, Nanoski, I really appreciate you coming on to this. At first, I really thought you were going to be against it.
You know, there's an ongoing debate, I think, in the scientific community about whether to confront someone who is a science denier, because that's ultimately what I told him. That's what I said at the end there.
Yeah.
Ultimately, he's a science denier. It's not just it's not the flat earth thing. He's rejecting all kinds of branches of science to try and make the flat earth work for him. And, you know, in the science community, there's like basically two sides, like don't even engage these people. Would you even want to have a debate with someone who's rejecting such a basic aspect of history, right? So there are some who would say, don't even engage them because then you're giving them attention.
Right.
You're giving this false idea attention. You're just by you showing up, you're elevating it. But I'm on the other side of that. And I think like, if somebody's going to put something out there that's demonstrably not true, I think as a science educator, I have an obligation to go wherever that's happening and try to counter it. Just not let it run free across the internet. Like somebody has to like stand up for science because there are a lot of people out there that they don't got the time. They don't got the time to be reading all these technical books and understanding the history of science and all the discoveries and all the breakthroughs in mathematics and physics. You know, people can't keep up with all that. I get it. It's complicated. It's always evolving and changing. We're always discovering new things, and people are busy, right? People got busy lives. They can't necessarily keep up. If that's not your job, you're going to have a hard time keeping up.
Mm-hmm.
So when there's a situation where you can counter something totally untrue with actual facts, and it's something that can be done within, an hour's time, like on a podcast or something, it's something someone can listen to while they're working out. There's something they can do, and it gives them a chance. They got to hear both sides, most definitely.
Yeah. And again, that was the whole point. Like, I knew I was against it, but I didn't fully understand the why. And I think that's what I wanted to understand for myself. Like, I know now why I'm still against it.
Yeah. And here's the crazy thing. Oh man, I wish I could show this. He didn't get to use it, but there's a picture of Jupiter.
Mm-hmm.
And he tries to show a picture from 2014. And
2016 or something.
And the 2016 version has the Aurora Borealis up at the top.
Mm-hmm.
And he says, NASA used the same photo and tricked us. It's the same photo. But if you go to actually NASA's website, they tell you it's a composite photo. They readily admit on the NASA site of that image, we took two images. We took an image using the visible spectrum. So the part that we can see with our eye, we used that lens filter to take that picture of Jupiter in visible light. We then used a ultraviolet lens to pick up the ultraviolet photons in the Aurora Borealis on Jupiter. So they're using a totally different lens, focusing on a totally different frequency of the electromagnetic spectrum. And then what they did is they took the visible light image and the ultraviolet one, and they superimposed them on each other so you could have the best of both worlds when you saw Jupiter. You could see all the stuff you could see with the normal human eye, but they illuminated the Aurora Borealis in ultraviolet. And it says literally on the NASA website, that's what we did. They literally say this is a composite from 2014 and 2016, and they tell you exactly why they did it. Not some conspiracy. NASA's not lying to you. They literally tell you what they did underneath the image. But he makes it sound like in his little presentation, so he didn't take that slide out today.
I had seen it on YouTube.
I seen it on all his other presentations, but he didn't take it out there. I was ready to jump on that one. Like, that's the one thing I want to make a point about if he brings it up, because that means you're willfully lying.
Yeah.
You either didn't read, which means you're not a very curious person, or you knew it said that, and you're demonstrating this to your audience, knowing that what you're saying is not true. It's one or the other. You either didn't read it because you didn't care to, or you did read and you know that they weren't lying to the public and you're saying it anyway.
What's crazy is just like the whole thing that objective truth nowadays seems like nothing,
I think part of the problem, and I don't know if this is going to be controversial. I think part of the issue is there's this whole kind of wokeism thing that's going on. How woke are you? Whether you're woke about your history, whether you're woke about your race or your culture, whether you're woke about the racist history of the United States, all this wokeism, people kind of discovering their personal truths and their personal histories and stuff. There's a good aspect to that. It's good to know where you come from. It's good to know history. It's good to know these things. But I think it also gives people a license to kind of make up their reality. It gives them the license to kind of pick and be kind of like what he did, cherry pick. I'll cherry pick the things I like and I'll ignore the stuff I don't like. Right. I want to believe my comforting lie. So I'll pick the things that are going to reinforce it. But all the other stuff that contradicts it, I'm just going to pretend like it doesn't exist, or I'm going to say it's racism, or I'm going to say whatever I got to say to say that side's wrong. Right. It's like saying that because a lot of scientists were white men early in the history of science, which is totally true. Sexism was a rapid thing. It still is. Right. Science had got a lot of sexism in it. Science had a lot of racism in it. It was dominated mostly by white guys for hundreds and hundreds and hundreds of years. But to say that Ptolemy or Aristotle or Copernicus or Galileo or Einstein to say that their discoveries are somehow invalid because they were a white guy. See, that's where you go wrong. You're like, well, that's white science. So
yeah, that happens a lot nowadays.
So if you're a woke person and you're against whiteness and you're against white society and you're against white guys, then whatever they discovered, it must not be true. It's racist. You know, but I'm just saying people can make that argument themselves, and they can reject mathematics and they can reject facts and they can reject all these things that we've proven. It wouldn't have mattered if someone from India had discovered it or someone from Mexico had discovered it. The fact that it was discovered by white dudes because it was during a time in history where white males dominated science, somehow that's got to all be rejected.
Yeah.
So objective facts are objective facts, no matter who discovered them.
Yeah, exactly. That's stepping away from your own biases, any bias, and just seeing it for what it has proven to be.
Yeah.
Fuck.
I'm glad you gave the forum. I'm glad that this particular go around was a lot more, I think, of a give and take, as opposed to just like a let the train run away.
Oh my God.
Man, when he said that there were no cone-shaped mountains that were volcanoes,
oh my God,
I don't even know. My brain almost exploded. I was just like, I know when I brought up like Mount Shasta and Mount St. Helens, and I said, you do know that if you drill into the side of any of those volcanoes, they have layer after layer. They're literally made of layers of lava. Like he literally was saying, if I don't see an eruption happen with my own eyes,
they're
it's
not
not
real.
a volcano. And I'm like, we got dormant volcanoes. We got volcanoes that like last erupted 200,000 years ago. So no one's seen that thing erupt for 200,000 years, 80,000 years, 50,000 years. And you're going to deny the rocks that make it up when we know they're lava rocks and there's layer upon layer, eruption after eruption, making it get bigger and bigger and bigger and bigger and bigger. You're literally rejecting what it's made of. And he rejected it. He says, I reject that. I was just like,
as clear as day. I know.
If you can't believe in volcano, I don't even like to use the word believe. If you can't accept that volcanoes exist and they erupt lava, that magma comes from the mantle of the earth and under pressure gets pushed to the surface and exits a volcano. If you can't even accept that, then you're kind of beyond hope. you obviously, that's why you don't want to take that trip on the rocket. You don't want.
Your whole world falls apart at that point. Like your whole sense of identity and what you've been doing, it's going to fall apart.
Yeah.
Nanoski, thank you for making the time. And again, this is the second time I have you on the show. Hopefully it's not the last. Next time we have somebody else coming out here trying to question reality. But dude, thank you so much again. And for the people out there, you know who Nanoski is, you know where to find them. And thank you once again.
Yeah, thank you. Thank you for doing this.
But we'll catch you next time, all right? See ya.
For antidotes, too many lovers that scatter hoes, and I'm just living the shadow world. Feels like the end of the fucking world. Feels like the end of the fucking world. Too many lovers that scatter hoes, and I'm just living the shadow world. Feeling like nothing gon' matter, so I'm just gonna relax. Too many lovers that scatter.